If a balloon is taken from inside a house where the temperature is 72 degrees Fahrenheit to the outside where it is 55 degrees Fahrenheit, by about what percentage will the balloon's volume shrink when it has cooled to the same temperature as the outside air? So the concept I'd like to use for this is Charles' law, which is that volume is proportional to temperature. And that suggests that if I have, say, a ratio of two volumes that correspond to two temperatures for the same system at those two temperatures, that this sort of stacked proportion should govern that. So that's kind of how I'd like to look at this. And so what I'm going to do is I'd like to actually calculate the temperature ratio. And that looks really, really simple. Like, okay, does that mean I'm just going to do either 72 over 55? Or should it be 55 over 72? Or would neither of those be correct? Because this assumes Kelvin. This is coming from the ideal gas law, or it was the thing that led to the ideal gas law. And this is supposed to therefore be the absolute temperature relative to absolute zero. So we're going to actually have to convert both of these temperatures to Kelvin in order to actually do something with them. So let me start with the 72, and the way I'm going to start by converting to Celsius. So I'm going to subtract 32 and then multiply that by 5/9, and then with a little calculator help, I get for that 22.222 repeating. For the 55 degrees Fahrenheit, I'll do the same thing. And my calculator finds for that it is 12.7 repeating in degrees Celsius. Now, if I want to find the ratio in Kelvin, I'm going to have to add 273.15 to both of these. What I'd like to do, it asks for the percentage that the balloon's volume will shrink. So I'm going to take the lower temperature over the higher temperature. And then, if I get like let's say I got something like 0.95 for that, I would interpret that as a 5% reduction. So I'd be able to read off of that what the percentage change is, assuming that the higher temperature is what corresponds to 100%. So in this case, the way that would look is I'm going to put in my calculator 12.777, and I put at least 8 or so of these. I'll just put ... here, plus 273.15. I'm going to take that whole quantity divided by the larger temperature in Kelvin of 22.222, and again I put in more in the calculator to make sure that I didn't have too much round off going on. Add to that 273.15 to put it in Kelvin. And of course in the calculator I had to put this in inline and use some parenthesis symbols to get it all to make sense. And then my calculator, when I did all that, gave me the number 0.968, and then it was 0.252788. But I think I've got enough there because this is 0.032 less than 1, which suggests a 3.2% decline in volume. So I think that 3.2% addresses the question the way it is worded when it says about what percentage will the balloon's volume shrink when it has cooled. So let's go ahead and check that. There it is, 3.2%.